Hello friend, I'm Soumyadeep back to the new tutorial video regarding soil mechanics. In this video, I'm gonna talk about the first soil structure, that is single grain soil structure. From this video, you are learning why it is single grain, what type of force acting on single grain, what is the relation with relative density, that is the ID, positioning of particle. Watch the video till the end, brush up your concept, enrich your knowledge. If you are new in my channel, make sure to subscribe and press the bell icon so you don't miss out on my future video, because I'm coming with this type of video. Before starting the single grain soil structure, I talk about various types of force, various types of bond. So in case still if you are not watching, there will be some I button, please click and watch it. First we are talking about why this is known as a single grain soil structure. Or before talking about single grain soil structure, first tell you something. We know the range of soil particle. First comes gravel, then sand, and then clay and silt. Gravel, that is 80 mm, sand 4.75 mm, and clay less than 4.75 mm. Gravel to sand, they are cohesion less soil. From clay and silt, they are cohesive soil. Practically, you can say size of cohesionless particle is very bigger than size of cohesive soil. But if dia is d of this material, and if diameter greater than 0.02 mm, in that case all particles are settled down due to gravity. All particles settle down due to gravity. Now you can say me, sir, why not surface force not acting? Because when diameter is greater than 0.02 mm, this particle have a particular mass m, surface area is SA. So diameter when greater than 0.02 mm, then mass is comparatively high rather than surface area. As mass is comparatively high, gravity force comparatively high rather than surface force. That is why diameter is greater than 0.02 mm. In that case, gravitational force is dominating in this type of soil particle, is generated by weathering action. Sometimes soil transported by gravity. So suppose this is a place and where soil is settled down by gravity, and it's take time. Here the particles are settled down by gravity force gradually. Here a new types of soil is generated. But if you want to see in your naked eye, then that is not a proper example. In that case, what you should do, you take a beaker, there is a water table, and you just drop the soil particle. If the soil particle diameter greater than 0.02 mm, they are settled down due to gravity action, and here they are settled as a single particle. After settle down, each and every particle creates, or better to say make, some contact with other particle, and finally they make a structure. This structure is known as what? Single grain soil structure. Concept is clear. Why this is single soil structure? That will be clear. So I can say this is your definition. Tell me the example. So before starting the example, I show you one thing. Particle size more than 0.02 mm. That means particle range means 80 to 02 mm. So this type of soil is cohesionless. So example is cohesionless soil, or you can say cobble, gravel, sand, etc. So my humble request, go with your concept, try to less memorize. Now I talk about force. What kind of force acting on this soil structure? Very simple. Gravitation force. Why gravitation force? Because diameter high, mass is high rather than surface area very less. That is why gravity force high and surface force low. That is why for this structure gravity force is more dominating. Few days ago I talked about relative density. Can you remember relative density? What is relative density? If you remember, then just do comment in comment section what do you mean by relative density. Relative density, that ID, that is equal to E maximum minus E natural, E maximum minus E minimum. In this video first time I link between two things. One is ID and one is single grain structure. What is the Emax, what is the E minimum, and I say you some particular value. I hope you heard about this. Let's see how the Emax is generated and how the E minimum generated. Before saying this, I gonna tell you one more thing. Suppose one of you can ask me, sir, this settlement is happen, maybe there will be generated two cases. Case 1, this is the place due to gravity, soil is settled here and soil are settle very close, more close, void, less void ratio minimum. Experimentally, if single grain soil structure placed diagonally, then generally what happen? If they are placed diagonally, in that case void space getting very less. In that scenario, diagonal value of E minimum 0.31 that I mentioned in my previous video. This is the case. Case 2, same. This is the place due to gravitational force. Soil are placed haphazardly. If soil placed haphazardly, closeness very less, void space very high, void ratio should be high. Practically or empirically, if soil structure are in cube format, their void space is much more, and that is the maximum, and that Emax equal to 0.97. That also I talk about previous video, and this is known as a cubical placed. So that in this manner we are getting Emax value as well as E minimum value. We put here Emax and E minimum. So when we are working on a cohesive less soil, then we have to find E natural, then we have to find Emax, E minimum, and then found out ID. So depend on ID value, we are deciding how much compaction we need. And this everything happened why cohesive less soil are single grain where gravitational force acting. In that case, suppose there is a surface force is acting, then there is some other thing. And one more thing I discussed in last. So case 1 is a dense state and case 2 is the loosest state. That's it from my side. In this video, I am talking about single grain soil structure, where I discuss why this is known as single grain structure, as well as what is the definition. Then we talk about what type of force is acting here. Then I am showing the relation between relative density as well as soil grain structure, and I am showing the probable two case of making their orientation as well as placing as well as placement. So if there is any kind of doubt, do comment in comment section. Still, if you are watching my video, subscribe my channel and press the bell icon for never miss an update, because I am coming with this types of video almost every day. Thank you for watching this video. More knowledge, more opportunity.